Good morning, good evening, and good night to everyone watching us or listening to us at any point. With us today, Jesús Bonet. He's the Director of Sales and Business Development at Hexagon Geosystems. And we're here with Rene Nazario. He is the CEO of Visual K. Jesus, thank you for joining us. How are you?
Thank you very much. I'm very happy, very excited having this session. So thank you very much for the invitation.
Rene, thank you for joining us as well.
Hi guys, well, that's a pleasure always, and Jesus, always good to engage with all the great things that are going on. I think this specific topic that it's about reality capture and digital twins, there's a lot of buzz in the market, things you hear, right? But some people, are asking, hey, how do I apply it? What is it? How do I touch it?
Yeah.
So I think this one, it's one that's very interesting. It's very relevant for the time that we're living. And it's something that I think our listeners are eager to hear about.
Yeah, it's we are making some noise with this reality capture and this integration with EAM. So people is getting really interested about this. So looking forward to what we can show and what we can present to the market.
Super. So I'll get straight to it, Jesus. So I think that the first question to try to understand this, right? It's what is reality capture, right? And we talk about the digital twin, but how are they connected? And are they the same thing? They're different thing, and is it like through reality capture that I'm able to create a digital twin? Can you tell us a little bit about it?
Yeah, of course, Rene. So as you said, the final objective of this integration or of this discussion in the end is to get this digital twin, and we can get this digital twin in different ways. But basically, one of the best reasons or one of the best ways to do it, and is my favorite one, of course, is using reality capture. But let me start maybe defining or explaining what is reality capture for everyone. I like to define or to describe reality capture like the process of digitizing the real world through the use of different measuring technologies, different sensors. So the sensor is one important component of this reality capture process. The second one, of course, is the software, is the way we use the software to manage all this information in order to get the digital twin. And something very important, digital twin is not only the geometry, something that you can get with the reality capture technology. We need to put the information on top of this geometry in order to get the real digital twin.
That's very interesting. I think as we look at it, I mean, the applications of it, could be anything, right? I think when we talk about, I want to be able to capture the digital reality. And when we're looking about, industrial environments, right? And we're talking about digitalization, right? How does that work with, like, for example, if I'm thinking about, hey, how do I do maintenance? How is that going to help? Or, how do they integrate? Is there something there that's going on that can definitely help us, make it better, make it more friendly, more safe?
Yeah. So basically you are asking, how do we help with reality capture technology in order to run these maintenance activities within industrial facilities, etc.? I mean, I think in general, digitalization definitely improves the asset management aspect. And from my point of view, Rene, it's all about asset visualization. So as we usually say in Geosystems, you can't manage what you can't see. So in the end, having this asset visualization for sure will help you with all the activities for your operation. So I think the key point is that our reality capture technology can be easily integrated into facility management software, into facility management activities. So basically you can transform the reality capture data into something that your EAM software can understand. This can be a 2D drawing, a 2D floor plan of your facility, a 3D model. We can even directly integrate the reality capture technology with other technologies like TrueView. So in the end, we bring you the different possibilities to have visual access to all the facility, to all the assets. This is in the end giving the user the opportunity to visualize the asset. And of course, this is in the end giving the user a rich digital twin that for sure will help the user to maintain and operate the assets in real time, in real life.
Super, thank you.
Yeah. So, Jesus, this is a rather new technology. What are some of the challenges that reality capture will or might be facing at this point?
Yeah, I mean, in the end, it's new technology, but it's not so new. I mean, reality capture started like 20 years ago, but it's true that it's now in the last 5, 6, 7 years when reality capture is becoming really popular in different segments. We are speaking today about industrial facilities, but hey, we are using the technology in buildings, we are using the technology in patrimony, in a lot of different industries and segments. So it's true that it's now when it's becoming really, really popular or well known in different industries. What we are solving, which kind of problems or which kind of challenges we are overcoming? Well, I think having an almost perfect replica, digital replica of the real world is a dream. And in the end, this is a digital twin, having the digital replica of the physical world. And this is something that we can do with reality capture technology. And as I said before, not only in industrial environments, but in a lot of different industries. So first of all, I think it's the quality of the data we are capturing. There are other technologies to capture the reality, but definitely reality capture brings the user high level of accuracy, high level of definition, and then you will have a very rich 3D information of your physical world, of your physical object. So in essence, it's about high quality, high definition, and very, very important, very fast. We can capture the reality super, super fast. So this combination of acquiring the physical world super fast with high accuracy, I think is in the end the main characteristic of this reality capture technology. This means that the user can avoid reworks. This means that the user can reduce the number of visits to the site. So in the end, the 3D representation of the physical object with reality capture gives the user the ability to predict and prevent problems before they occur. And I think this is very important for operations and maintenance.
Yeah, and you mentioned, this is when you can't see or can't have any information, then you can manage an asset, right? How are these digital twins, helping you in doing testing, simulations, and to what point are they? What's the precision on them?
So by creating a digital copy of the reality, of course, you can simulate tasks. And I think this is, of course, one of the most important things. I mean, it's important to capture the reality, but it's even more important, what do I do with this information? So I need to use this information. As I said before, I can transform the information into drawings or 3D models. That is something that you can use in your EAM software for operations and maintenance. Now think about safety and security. Imagine an industrial environment and you need to create a training for the people working in this facility. You can use this virtual environment to do this training. Imagine we are not speaking about operations and maintenance, and we are speaking about other phases, design or construction, or even in operations. Imagine you need to change an equipment in a boiler room. Imagine there is a boiler machine that you have to change. You can use the reality capture technology to bring again the technology to your laptop, to your office, and then by designing the new boiler machine, the new boiler instrument, equipment that needs to fit in this room, you can simulate, you can check if there is any clash between the reality, so the reality capture information, and your 3D model design. So going back to your question, yes, definitely digital twins will allow you for testing and simulating.
Awesome. Yeah, so you said earlier that this is really frequent information being captured. Are we talking minutes? Are we talking seconds? Is it, how frequent is that data that is being captured?
I mean, I think there are two things. One thing is the speed we have during the acquisition, and this is something we can do super fast because we have technology that can acquire up to 2 million points per second. So basically, imagine a house with, I don't know, 5 bedrooms can be easily captured in, I don't know, less than 5 minutes. So it's a very, very fast technology. The second part of the question maybe is how frequently you need to scan your facility. And this is a very good question in the end, because I mean, when you are scanning, the data only needs to be captured once, and you have the data forever. But what happens if the facility is changing? And this is very frequent. Let's imagine you have an industrial facility that you scanned it, I don't know, 2 years ago. But now we are introducing some changes in one part of this facility. Of course, you need to scan again, but we have different software solutions to easily recapture the area that is changing now. And now we can incorporate, we can bring this new data into the old acquisition, and we can substitute the outdated data with the new one. I think this is a very important discussion when it comes to scanning big facilities, because they are changing fast, and it's very important to have everything updated. So yes, we have to rescan, and yes, we have software solutions to update the new information into the plant. In the end, this is bringing something very interesting, because you have a 4D component of your facility. You have your facility 2 years ago, and now you have your facility or this new area as is of today, you know, and now you can compare. This is very, very useful for design and construction if you want to compare different phases of the project.
Yeah, it definitely makes sense, because in an industrial environment, you have moving parts all the time, right? And specifically, I'm thinking manufacturing, they have a lot of machines moving in and out. They place them depending on what makes sense at that point. And it definitely is something that really applies, because you are every time you're shifting the environment there.
It's a very recurrent discussion when it comes to retail shopping centers, as an example. They are changing constantly the image, brand, etc. It's very important for them to renew the scans and to, you know, adopt the new scans in the full reality capture project, you know, and this is something very, very important.
Right.
I think it's very interesting, and when we start talking about the ways that you can scan, right? Now we get a little bit into the technology, right? I assume that, you know, there are different things. In my mind, I can see the drones, I can see the robots, I can see a lot of things. So tell us a little bit, Jesus, how do you define all those technologies, and how are they, you know, best applied, you know?
Yeah, so that's really exciting, and it's a very good question, you know, because depending on the project, depending on the scope of your project, then the technology needs to be different. I started working in this business like 20 years ago, and we were measuring point by point with the total stations and other technologies, you know. But then the reality capture arrived, and this was the revolution for the geomatics, for the geosystems technology, you know. So now, during these 15 years, it's impressive how the technology is evolving, how fast, how accurate, how easy to use is now this technology is something really, really impressive. I like, when it comes to reality capture technology, I like to define in three main pillars or blocks. First of all is terrestrial laser scanners. Second one is mobile mapping systems. And third one, this is like the state of the art. This is the autonomous solutions. So TLS, terrestrial laser scanners, this is the static measurement. So you place a scanner, an instrument in a tripod, and then you are scanning super fast the environment. This is usually more accurate, not so fast as a mobile mapping system, but it's much more accurate. If you need more productivity, if you need to go faster, then mobile mapping solutions usually are the best solution. Mobile mapping solution in the end is a laser scanner that you can use while you are in movement. So we are combining the laser scanner with other technologies like GNSS, inertial systems, IMUs, etc., cameras. And while you are walking or while you are driving, you are able to capture the reality. This is usually less accurate, but much more productive. And then the third one, as I said before, like the state of the art, is how Hexagon Geosystems see the future. And this is in autonomy. I mean, this is using autonomous solutions. We want to reduce the human interaction with the technology. And in the end is using UAVs, as you said before, drones, or using robots and putting the sensors in those robots or drones, and then they are doing the measurement for us. So this is like the dream of the people surveying or measuring in the facility. So basically, these are the three technologies: TLS, more accurate, less productive; mobile mapping, more productive, less accurate; and then autonomous solutions, trying to avoid the human interaction.
Wow, that's very interesting. And I assume depending on what your goals are, then you will define which technology you use, right? So depending on the application and what you're trying
exactly, that's really important. And usually is accuracy. If you want to create a 3D model of your facility, what level of detail you want to get? Depending on this level of detail, you need to use one technology or the other, or how fast you want to go acquiring the information. This is, in the end, which is important to decide which technology I want to use in the project.
Wow, that's interesting. My mind goes into different places and things that we could do, right? I think it's amazing that this technology is available today. So as we have a lot of people that take care of facilities and different plants and large engines and all sorts of assets, and they're hearing this, say, hey, might be interesting for me, right? Could be something that I might, like to apply, but they start thinking, how do I start? How much is going to cost? How do I justify this type of thing? So what recommendations would you give, for the managers that are, considering starting to implement these technologies to try to, optimize their plans and go into the next steps?
So René, this is probably the most important question of this discussion, because in the end, why should I change the ways of doing things? This is or what this technology is bringing to me, or that's definitely a very good question. So first of all, what I would say to all these people seriously considering of adopting the technology is, don't be afraid. I mean, don't be afraid of adopting new technology in general, but adopting reality capture technology in particular. Don't be afraid of changing your processes. And this is a very important statement from my point of view. So things like, we always did it in this way, is something that we have to remove from our minds, because I think there are a lot of nice technology in the market to be adopted, and this is for sure going to help me to improve things. So leave the comfort zone, try new things, and probably you will be surprised about how much time and money you can save by using this technology. Maybe the second advice or recommendation would be, why not starting with a pilot project? I mean, all right, this is a new technology for you, and you are not totally convinced about this. But maybe you can start with something small, pilot project, proof of concept, something that allow you to test the new technology, the new workflow without risks. So in the end, we from Geosystems, or you from Visual K, you are going to support the end user with this journey, and we are going to show the people how to use the technology in a very small project, and then with your own experience, you will be able to really decide if this is interesting for you or not. And I'm pretty sure that it will be interesting. And once you are sure, of course, the only thing you have to do is implementing, and then again, we are here to support with this implementation. So for me, these are like the three main recommendations. Okay,
so they don't have to go and buy everything and get it going. You're saying, hey, come to us in Hexagon Geosystems, and we will be able to help you create a proof of concept, something that you can understand what that means to your business, right? Where's the value in it, right? So what am I gaining from it, right? And then obviously kind of do an ROI and figure out, what are the returns. I mean, so I think that's amazing, because like you said, you can dream about it, but then you figure out, how do I get there, right? So good that Hexagon
René, in the end, the technology is more or less affordable, depending on terrestrial laser scanners, if it's an entry-level solution or high-end solution or mobile mapping. But in the end, it's an important investment. So if before forcing the customers or the people, hey, go and invest for this technology, I think there are other formulas to really help with this process. One is the pilot project, as you said. Rental could be another option. So we have different services to help the customer to access the technology. And then once they are ready, once they are totally convinced, they can consider about the investment. But yes, we are very flexible with this.
Super. That's very exciting and very interesting ways to go about it. Thank you for that, Jesus.
Thank you to you, Rene. Thank you, Ernesto, for the invitation. And yeah, happy to support. I'm here. Thank you very
There you
much.
have it, folks. The future is here. I'm
Yeah.
very excited about this one. So thank you both, Jesus, for joining us. You know, from our side, you can find our post on LinkedIn, Twitter, and Visual Case blog. And also listen to this and any other episode on YouTube, Spotify, Apple Podcasts, and Anchor FM. So thank you, Jesus, for being with us, Renee, as well. Thank you very much. And you know, this is it.
Thank you very much. Bye.
Thank you, guys. That was very, very interesting, informative. Appreciate it. Always a pleasure talking. And until next time, take care.
Thank you. Bye.